This section of the course will look at the very wide range of research and development areas that have been explored in AI planning. It'll put AI planning techniques in the context of domain modelling and plan representation, consider engagement with users, task assigners and decision makers who must select between plan options, and will include the important aspect of plan execution for practical systems. The course logo shows a number of applications of Edinburgh AI planners over the years. The Nonlin planner was used in the mid-1970s to generate project plans for electricity turbine overhaul. The project plans in this case were prepared well in advance because it's costly to have these machines out for any length of time. But while the repair is taking place, typically problems are found, extra maintenance operations need to be injected. So the plans had to be adjusted as you went along, and Nonlin was able to do that. In the late 1970s, Steve Veer at NASA's Jet Propulsion Laboratory created the Divisor Planner, which was used to generate action sequences for the Voyager spacecraft, though it wasn't used for uploading live action sequences to Voyagers. Divisor was based on the Nonlin design but added the ability to represent time windows on the activities, which is important for this kind of robotic application. Nonlin's hierarchical task network approach was also used in some of the early research on the robots in Japan. Assembly, integration and test of the payload bay for the European Ariane rockets was carried out using a planner based on the O-Plan design. O-Plan has also been used in a wide range of applications in emergency response and search and rescue. Edinburgh AI planners have also been used in applications as diverse as help desks, tanker delivery and many others. Even the earliest AI planners were used in realistic and practical applications. The STRIPS planner from the early 1970s was used to control the Shaky robot. And as you can see from this table, there's a range of planners over the decades which have been applied to a wide range of application areas, and we're going to cover some of those in a later module of this course. As part of this course, we're going to encourage you to look at a number of readings. In particular, there's 2 reviews of AI planning which we hope you'll find useful. One is from the 1990s, so it's quite dated, but it does include a lot of the work on those early planners and some of the formative techniques that's used in them and that you'll learn about on this course. That's the Hendler, Tate and Drummond paper in AI Magazine on AI planning, systems and techniques. There's also a review a decade later by Wilkins and Desjardins on A Call for Knowledge-Based Planning, where techniques of knowledge-based systems and planning were being brought together. Full details of these readings and the locations where you can find the PDF copies of them will be available in the course wiki. Then there's a number of readings, some of them very short readings, on specific planners and their applications, and we hope you might dip into these during the course. If you've got time to read just a couple of these are the ones which suggest the initial review of AI planners to 1990 and a very short paper on O-Plan, one of the Edinburgh planners, which looks at a wide range of techniques and applications that were in use in that system. There's a diagram in the 1990 review paper which tries to trace some of the historical connections between the different planners, the techniques they drew on and how they built on one another. It's worth looking at that in detail. Perhaps you could pause the video at this point and take a good look at some of the techniques and areas in there. There's an online version of this diagram also available at high resolution if you can't see it in the video that you're using.